This is Calculus 2. This session, we're going to study integration by part. Previous session, we studied substitution method. I'm going to introduce new integral technique this section. Before we introduce integration by part, let's review product rule of derivative. So let's talking about product rule. Product rule. So what is a product rule? So let's take a derivative of fx times g of x. Or another rotation, fx times g of x, take a derivative. So what is gonna be? This one gonna be derivative of first function, g of x, first function, derivative g prime x. So that's you're gonna find it, right? So now from the definition of indefinite integral, you're gonna see this form is gonna be changed this way. This one is fx g of x integral f prime x g of x dx plus integral fx g prime x dx. Another we integrate both sides, you're gonna have this one. Now, you rearrange this a little bit, guys, okay? So what are you gonna do, guys? Look at this one. Then I'm gonna move this one is left side. So fx g of x minus integral f prime x g of x dx equal integral fx g prime x dx. Now, I'm gonna exchange left side, right side, then you're gonna see it integral fx g prime x dx. So I'm gonna move this one is left side. This left side is right side. Fx g of x minus integral, this one first, g of x f prime x dx. We call this integration form is integration by parts. Previous slides, I'm gonna introduce what is integration by parts. Integration by parts from the product rule and take integral both sides. That's gonna be we see integral f of x g prime x dx fx gx minus integral gx f prime x dx. More simpler form is right here. You're gonna be fx, you're gonna be f prime x. So here is integral fx g prime x dx. Now you're gonna see it. You're gonna be f of x, you're gonna be f prime x dx, v gonna be gx, dv gonna be g prime x dx. So this is gonna be changed. So fx gonna be u, g prime x gonna be dv. That's you're gonna change it, guys. Okay. Then right side here, fx g of x minus integral g of x f prime x dx. How gonna change this one? Gonna be fx gx. That's the uv minus integral g gonna be gx gonna be v f prime x dx gonna be du. So simpler form of integration by part. Now you're gonna say integral u dv equal uv minus integral v du. What is the big challenge for the integration by part? Which one you're gonna pick the u? Which one you're gonna pick the v? Integration by part, it's not easy. What's the big challenge to use integration by parts? What are you gonna do the u? What are you gonna pick the dv? That's really challenging for the integration by part. Here is fundamental rule to use integration by part. So what are you gonna pick, guys? Here is a general idea. What are you gonna be u is that here is first you're gonna thinking of a logarithmic function ln x. That's the first choice. Second is inverse trigonometric function. Third is algebraic x squared, x cubed, x fourth, something like that. Fourth one is trigonometric function. Last one is exponential function. So most of the time when you see log and inverse trigonometric, that's gonna be u, guys. Keep in mind, that's very important, guys. So here is a pick the u, okay? So second is you're gonna find, after you decide the u function, so you're gonna find the u, right? Then you find it, and you find the dv, then you're gonna find the du and v. That's second part, okay? That's the second. Third one is you substitute into the formula. Formula gonna be integral u dv uv minus integral v du. You plug in everything in this formula. First one is simplify and integrate remaining part. It's a really long process, guys, so you have to make sure pick the right u, right dv. You remember log function is definitely you're gonna pick the u. Inverse trigonometry is u too, guys, okay? So there are three cases for integration by part. Case one, I call this one is a case one. Look at this form. Here is the polynomial function. Here, exponential function, product of two different kind of function, polynomial functions, trigonometric function, polynomial function, trigonometric function. Previous slides, we talking about which gonna pick the u, which function we're gonna pick the u, but order is log function, inverse trigonometric, polynomial function, then trigonometric function, exponential. So this is polynomial function is before the exponential and trigonometric function. So I'm gonna do this case gonna be u gonna be xn, dv gonna be exponential function, or dv gonna be sine or cosine function, okay? That's a keep in mind. So also I'm gonna write down the formula for this integration by part. udv equal uv minus integral v du. That's the integration by part. Let's try first one. So here you go, here. U gonna be x. dv gonna be e to the x dx. So take a derivative of u. du gonna be 1 dx. V gonna be, take integral dv gonna be e to the x. Now using this formula, you're gonna see integral u dv. That's gonna, you have x e to the x dx equal. Now u dv, uv, so x e to the x minus, make sure this is minus, integral this one times this one, v du, e to the x dx. Can you see that? So now you need only take integral, the second part, x e to the x minus antiderivative e to the x, e to the x plus c. That's how to find the first example, okay? Let's try the second one. Idea is the same. Polynomial before the trigonometry. So you're gonna pick the u gonna be x, dv gonna be sine x, dx. Differentiate u gonna be du gonna be take a derivative of x is dx, 1 times dx. Integral v gonna be integral. What is antiderivative? Sine is negative cosine x. Okay, so now second part, integral x sine x dx. See that? This one is gonna be u. This is dv. So then we're gonna have here uv. uv gonna be x minus cosine x minus integral v du minus cosine x dx. Here negative positive negative x cosine x negative positive integral cosine x dx. So negative x cosine x antiderivative cosine sine x plus c. So it's getting comfortable with this idea. Let's try another example. We did case one. Case one is polynomial function times exponential or sine cosine. So let's go to second case, guys. The second case is gonna be polynomial function times log, polynomial function times arctangent inverse trigonometry, polynomial function arcsine. So ln u, when you pick the u, ln trigger is before the polynomial. So this time u gonna be ln x, dv gonna be xn. Okay, u gonna be ln x, or another way, u gonna be inverse trigonometric, so arctangent x, dv gonna be x and dx. I missed this dx, guys, okay? So let's write down the integration by part formula one more time. You're gonna keep using it. Integral u dv, uv minus integral v du. That's what we're gonna use, okay? So let's try first. Oh, this one is very careful, guys. Here is no ln x, but there's another one, which meaning is, so you're gonna pick the u is ln x. Then dv gonna be u times dv. This case is only dx, guys, because x dx is left. That's you have to make sure, guys, okay? So what is gonna be du? Differentiate ln x is 1 over x dx. Integral of 1, here is 1, that's not show it, 1 dx. Find antiderivative, 1 is x right there. So let's rewrite this one. Integral, this one is u, this is dv. Now this one is uv. So I'm gonna put the x first, x ln x minus integral v du. So x times 1 over x dx. Oh, x ln x. So you're gonna see cancel out minus integral 1 dx, which meaning is x ln x minus what is antiderivative 1x plus c. That's you're gonna find this indefinite integral. Okay, let's try second part, guys. The second part, look at this arctangent x, same idea, right? So I'm gonna put the u gonna be arctangent. I'm gonna just put, guys, dv gonna be same thing as dx. That's only left right there. So du gonna be, do you remember derivative arctangent? 1 over 1 plus x squared dx. If you forgot, you should review the derivative of fundamental function. V gonna be x. Okay, we're gonna do same thing. Dx. Here is, we put this is gonna be u, this is dv. So first step is uv. So x inverse tangent x du. So x 1 plus x squared dx. Okay, now look at this one. How can do this indefinite integral? Second part, guys. This one is you're gonna use substitution method. I'm gonna take this one is here, guys. Integral x 1 plus x squared dx. What is gonna be u gonna be 1 plus x squared, du gonna be 2x dx. Guys, make sure green one is integration by part, yellow one is substitution method. So this one is to change it. Integral 1 over u times x dx. X dx gonna be 1 over 2 du equal x dx. So this one is gonna be 1.5 du. So I find 1 over 2 integral 1 over u du. So this one is gonna be 1.5 ln u. So another way substitute back, you're gonna see L 1.5 ln 1 plus x squared plus c. First one is we use integration by part. Substitution method. That's what we did, right? So now, finally, arctangent x minus right here, guys, 1.5 ln 1 plus x squared plus c. It's a really long process, guys, but you have really focused to use both integral technique. Now, case 3. That's the last one, but really challenging one, guys. Now look at this one. They have exponential function and that's I give idea about which one you're gonna pick the u. So this case, guys. So you gonna be before the exponential. So you're gonna pick the u gonna be sine or cosine. dv gonna be exponential function. That's gonna be rule, guys, okay? That's much easier to use integration by part. I'm gonna write down the formula one more time. Integral u dv equal uv minus integral v du. So let's have this example, guys. So e to the 2x sine x. So I'm gonna pick, you guys pick the u gonna be sine x, dv gonna be e to the 2x dx. Okay, that's you're gonna pick it. So du gonna be cosine x dx. We gonna be very careful. What is antiderivative? E to the 2x gonna be 1 over 2 e to the 2x. Okay, now let's change this one right here. Integral e to the 2x sine x dx. So u is sine x, v gonna be 1/2 e to the 2x minus integral, that's gonna be integral what is it? 1/2 e to the 2x times cosine x dx. Okay, just simplify first. 1/2 e to the 2x sine x minus 1/2 integral e to the 2x cosine x. Oh, still have problem, right, guys? This part. Let's do, when you see this one, you're going to do one more time integration by part. So here you go. This time, you're going to be same rule. Cosine x dv going to be e to the 2x dx. Derivative cosine is negative sine x dx. V going to be 1/2 e to the 2x dx. Oh, no, e to the 2x, right? You take an integral. Now, let's do this part first, guys. Let's this part first, this guy's first. I'm gonna do integral e to the 2x cos 1/2 e to the 2x minus integral minus sine x times 1/2 cosine x 1/2 e to the 2x cosine x minus plus integral 1/2 e to the 2x sine x dx. Okay, guys, make sense? All right, now this one go to here, guys. Okay, so white one. Now let's plug in the yellow into this white integral. So what happened here, guys? Integral e to the 2x sine x dx equal 1/2 e to the 2x sine x minus 1/2. Plug in the big thing is right there. 1/2 e to the 2x cosine x plus integral 1/2 e to the 2x sine x dx. Let's just simplify this one, guys. 1/2 e to the 2x sine x minus 1/2, 1/4 e to the 2x cosine x minus, here is, guys, 1/2, 1/2, 1/4 integral e to the 2x sine x dx. Now, how gonna find this integration, guys? So we want to find this integral, this indefinite integral. Look at this one. Can you see the same thing here? We want to find this one. So let's put a gonna be integral e to the 2x sine x dx. So let's put this one is a. Then we're gonna find this indefinite integral. So this form of this equation change this one. A equal 1/2 e to the 2x sine x minus 1/4 e to the 2x cosine x minus 1/4a. So let's solve for a, which meaning is you're going to move this one is left side. So I have a plus 1/4a equal this one is write this e to the 2x sine x minus e to the 2x cosine x over 4. So let's simplify this one. That's gonna be a gonna be here 4. That's gonna be 1, right? So this one is 4a over 4 plus 1 over 4a. So this one is gonna be same thing. So this one is a 5a over 4 equal e to the 2x sine x 2 minus 4e to the 2x cosine x. So let's algebraically this one, same denominator, here is a 4, so you're going to times it, here is a 2, here is the 2, so you have this one, 2e to the 2x sine x minus e to the 2x cosine x. We are almost done. So 4 of a over 4 equal this one. So what you have to do, we want to find a value, right? A value. So what you have to divide by 5 over 4 or times 4 over 5. That's the idea, right, guys? So here is 4 over 5 times 4 e to the 2x sine x minus e to the 2x cosine x. Now you find a value. Simplify this one. This one is a 4 is gone. So you have 5 e 2 times e to the 2x sine x minus e to the 2x cosine x. So what is the answer gonna be now, guys? Now, what is the answer gonna be? Right here, A. What is A? Integral e to the 2x sine x dx. Here, 5. 2e to the 2x sine x minus e to the 2x cosine x plus c. Don't forget to see last time. When you do this process, you don't add the c, but you cannot forget the c on the answer because that's the indefinite integral. Let's practice integration by parts. We're gonna do the 3 different cases. When you do the integration by part, guys, first you have picked the u. That's the key point for integration by part. Let's try the first one, guys. So first one is here, guys. When you see this one, what's gonna be u? Can you see it? Polynomial exponential. So that case, you're gonna put u gonna be x squared, dv gonna be e to the x dx. So this part is u, this part is v. So what is the du gonna be? Take a derivative x squared is 2x dx. Integral dv, v gonna be ex. Now, this one is gonna be integral. No. Now, this one is uv. So x squared e to the x minus the integral v du e to the x times 2x dx. Oh, we still have trouble. This one, this part, all right? So what do you have to do? Can you do substitution method? No. So you have to see, rearrange this one more time. We're gonna use integration by part one more time, guys. Look at this one. You're gonna be this part, e to the, no, not e to the x, right? What is gonna be u, x, dv gonna be e to the x dx, du gonna be dx, v gonna be e to the x. Depreciate integral, depreciate integral. So now what do you have? x squared e to the x minus parentheses uv x e to the x minus integral u du e to the x dx. Oh, almost done. Now, when you see this one, can you find the antiderivative? Yes. So x squared e to the x minus x e to the x plus integral e to the x dx. We see x squared e to the x minus x e to the x plus e to the x plus c. So this function, this integral, you're going to have integration by part twice. Let's take a 5-second, 10-second break, guys. When you come back, let's try second practice problem. Polynomial ln x first, right? Dx is dv. So I'm going to rewrite this one. In dx. So you're going to put this is b ln x, dv gonna be x squared dx. Differentiate ln x, 1 over x dx in over 3. So now, so this one minus integral v x cubed 3 times 1 of x dx. Let's just simplify x cubed over 3 times 1 of x simply dx. So this one is x cubed 1 over 3 integral x squared dx and x minus 3 pressure. 3 times 3, 9, right? That's how 1 times x squared cube x cubed plus c. Let's practice case 3 for the integration by part. This one is e to the x cosine x, e to the x sine x. That's gonna repeat it. This one, let's decide u gonna be cosine 3x, dv gonna be x, du gonna be negative 3, v gonna be e to the x, right? So now, first step is uv, e to the x cosine 3x minus integral v du, e to the x negative 3 sine 3x dx. Negative, negative, positive, e to the x cosine 3x plus 3 integral e to the x sine 3x dx. Let's do one more time, integration by part, this function, right? This function. So I'm gonna put the yellow. Let's do this yellow part, guys. Okay? So this one is u gonna be sine 3x, dv gonna be e to the x dx, du gonna be 3 cosine 3x dx v gonna be e to the x. So this part gonna be, now gonna be, now after using second integration by part, parenthesis is gonna be uv. So sine 3x e to the x minus integral v e to the x 3 cosine 3x dx. Let's simplify this one first. E to the x cosine 3x distribute to 3 plus 3 times e to the x times sine 3x minus, can you see 3 here, 3 here, 3 times 3 gonna be 9 integral e to the x cosine 3x. Now let's find integral e to the x cosine 3x dx. So let's put this part gonna be a. This part gonna be a. So a gonna be integral e to the x cosine 3x dx. That's what we're gonna find it. So this equation gonna be changed a equal e to the x cosine 3x plus 3e to the x sine 3x minus 9a. So you're gonna do solve for a. So this one is gonna be 9a, positive 9a, positive 9a. So a plus 9a, that's gonna be 10a equal e to the x cosine 3x plus 3ex sine 3x. So what is a gonna be? Divide by 10 both sides, divide by 10. So this one is e to the x cosine 3x plus 3 to the x sine 3x over 10. So what is a going to be? Integral e to the x cosine 3x dx equal e to the x cosine 3x plus 3 to the x sine 3x over 10 plus c.